Hello friends, welcome in Pharma Talks. And today's topic is USP General Chapter 891, which is thermal analysis. So in today pharma sector, the thermal analysis is a very important topic. Okay, where with the help of thermal analysis, change of state, thermodynamic events such as change of state can indicate the identity and purity of drugs. Okay, so now the thermal analysis is a very important nowadays in pharma sector, and some instrument which based on the thermal analysis like DSC, this is the differential scanning calorimetry, TGA, thermoanalytical thermogravimetric analyzer, and if we talk about the past times, though for the term thermal analysis, some instrument like melting point analyzer also included in this discussion. Okay, so precisely what according to the 891, precisely thermodynamic event search a thermodynamic events, what change of the state, a change of the state can determine, it can indicate or determine the purity of the drugs. Compendial standard have been long established for the melting and boiling temperature of a substance. These transitions occur at a characteristic temperature, and compendial standard therefore contribute to the identification of the substance. Okay, so what does it means? It means that the compendial standard have a impurity in it to, if you want to identify the purity of the compendial standard or compendial substance, we perform the thermal analysis. With the help of this, we can estimate or identify the purity of the our standard, because if the impurity in the drug substance increases, it can affect the melting point and the melting point onset and the heat or enthalpy of the substance. Okay, so thermal analysis is the broadest sense in the measurement of thermal chemical property of material as a function of temperature. Okay, so what we do in a thermal analysis, we just measure the thermal physical chemical property of a material as a function of temperature. Okay, instrument method have largely supplanted older method depend on visual inspection. Okay, what does this mean? It means that in today's world we perform the thermal analysis with the help of lot of instrument with which is in CGMP regulation, which follow the CFR 21 regulation, and but in the oldest days this instrument is not present. So thermal analysis is performed with the help of melting point analyzer or all that. With the help of these instruments, what we have to find? Generally we have to find the dissolution, dehydration, decomposition, crystal perfection, polymorphism, the melting temperature, sublimation, glass transition, evaporation, pyrolysis, solid-solid interaction, and purity. Okay, friends. Okay, wait a minute. Okay. Such data are useful in the characterization of substance with respect to the compatibility, stability, packaging, and quality control. The measurement used most often in thermal analysis, that is the transition and melting point temperature by differential scanning calorimetry, which we talked earlier, that is DSC, thermogravimetric analyzer, TGA, hot stage microscopy, and the elutic impurity analysis are described here. Okay, friends. Now, transition and melting point temperature. What is the transition and melting point temperature? Now here discuss. As a specimen is heated. Okay, if you have a specimen means if you have a drug substance. Okay, we are in the pharma, so we talk about the drug substance. The specimen is heated. Transition can observe during the differential scanning calorimetry. Okay, differential thermal analysis DTA or hot stage microscopy. So if any specimen or drug substance is heated, transition was observed. Generally, you can understand it is with the help of this. If you heat anything, it can change their state. Means if you burn a paper, first it if you burn a paper or if you burn a camphor, what happen? If you burn a camphor, it's normally changed from solid state to gaseous state. What does it change? Knows it is known as the sublimation. Okay, so we will discuss more in detail. First, I will complete this. So DSC are generally available in two types. First is the heat flux DSC, second is the power compensation DSC. Okay, in heat flux DSC, what happen? Which type of DSC is known as the heat flux DSC? The heat differential between the sample and reference material is determined. With the help of heat flux DSC, we can determine the heat differentiation between the sample and the reference material. What is the power compensation DSC? The sample and reference material are maintained at the same temperature using individual heating element, and the difference in power input to the two heaters is recorded. Okay friends, what is the power compensation DSC? The sample and the reference material are maintained at the same temperature. Okay, so sample and reference are maintained at the same temperature using individual heating element, and the difference is power input to the two heater is recorded. Okay, what is DTA? Differential thermal analysis. DTA monitor the difference in the temperature between the sample and the reference. Wait. The transition that may be observed include those in table 1. Okay, what happen if we heat the substance? Some transition may be observed. So in pharma sector, what type of transition we observed during the heating a drug substance is I tabulated in a table 1. We will discuss later. In the case of melting, both onset and peak temperature can be determined objectively and reproducibly, often within a few tenth of a degree. It means that if you using a DSC and you characterize your substance, it is necessary to find the onset and the peak temperature, and they are the reproducible within the few tenth of a degree. Means if you heat any molecule and you got the onset is 122 degrees centigrade and the peak temperature is 125 degrees centigrade. So if we perform the 5 preparation and observe with the help of DSC, we get the same onset and the peak temperature, and only the difference in the few tenth of a degree. Although these temperatures are useful for characterizing substance, it is very useful for the characterization, friends, and the difference between the two temperatures is indicative of purity. The value cannot be directly compared to the visual melting range or melting point values, or which constants are the triple point of the pure material. Furthermore, caution should be used when comparing result obtained by different method of analysis. As we know that in oldest days, we use the melting point apparatus or melting point to perform the thermal analysis. So what happened? Optical method may measure the melting point as a temperature where the last trace of the solid coalesces. In contrast, melting point measured by DSC may refer to the onset temperature or the temperature where the maximum melting range vortex was observed. So, however, the vortex is sensitive to the sample weight, heating rate and the other factor, whereas the onset temperature less affected by these factors. With thermal technique, it is necessary to consider the limitation of solid solution formation, insolubility in the melt, polymorphism and decomposition during the analysis. So later I discussed that if the transition happen, if we heat the substance or if the special transition occur, what kind of transition we generally see in the pharma field. during the characterization or by using the DSC. If a solid is changed to liquid, it is known as melting. Means solid substance, if we heat the solid substance and it melts to give the liquid, it is known as the melting. This transition is known as the melting, and this is the endothermic reaction. If a liquid change to gas, it is known as a vaporization, and it is also endothermic reaction. If liquid change to solid, okay, if liquid change to solid, it is known as freezing or either crystallization, and these both are the exothermic reaction. Solid to gas, okay, solid to gas. Just I discussed earlier, if a camphor was heated, it is directly changed solid to gas. This type of transition is known as the sublimation. It is the endothermic reaction. Okay, glass transition, it is a second order event. Glass transition temperature is a second order event. It generally happen in a amorphous solid. Okay, desolvation, it is also a endothermic reaction. So if we solid to gas, it is sublimation, and it is known as endothermic reaction. If solid to solid change हो रहा है, if the change is observed in solid to solid, so what type of transition will be occur? It is glass transition, it is desolvation, amorphous to crystalline, or polymorphic. Okay, if we transition occur solid to solid, it means it is a glass transition. It is generally happen in a amorphous solid, and it is a second order event. Desolvation is an endothermic event. Amorphous to crystalline, if a amorphous solid is changes to crystalline solid, then it is known as a exothermic reaction. And polymorph, if the one solid have a one polymorph and changes to another polymorph, it is either endothermic or exothermic reaction. Okay, next. Reporting result of instrument method. A complete description of the condition employed should accompany each thermogram. Okay, I just want to give one thing. The data which we obtain from the DSC, TGA, or with the help of thermal analysis technique, this data or the graph is known as the thermogram. Okay friends, the data which we obtain, it is known as the thermogram. Please remember this. In a complete description of the condition employed should accompany each thermogram, including make and model of the instrument, record of the last calibration, specimen size and identification, including previous thermal history, contain identity, flow rate and the pressure of the gaseous atmosphere, direction and rate of temperature change, and the instrument and record sensitivity, determination of transition temperature, melt onset temperature and melting point temperature. So if we want to determine the transition temperature, usually the melt onset temperature or melting point temperature, it should be determined with the help of DSC, differential scanning calorimetry. We use DTA or DSC instrument equipped with a temperature programming device, thermal detector and the recording system that can be connected to a computer unless otherwise prescribed by the specific monograph for which the chapter is being used. Calibration of the instrument. If we using DSC, so it is often that we calibrate our instrument. So if we have to calibrate the DSC, two type of calibration we have to perform. First is the temperature and the second is the enthalpy changes calibration. So our USP General chapter indicate that the first substance we use for the calibration, which is the indium, or secondly according to me I recommended indium near about use as a 150 around the temperature. Indium has a temperature in peak temperature or enthalpy change is near about 150 or 156 degrees centigrade. So according to me, if we perform the analysis and the analysis or your analysis, you got the temperature below 156 degrees centigrade, it is accurate with the help of indium if you perform the calibration with the help of indium. But if your substance have a high melting range, high melting point, then if you use indium only for the calibration, although you should not probably say that your melting point temperature is correct or not. Maybe your instrument is not working in the upper side. Okay, so by eliminate this type of things, you have to calibrate your instrument at the lower range, at the higher range also. So for the lower range, at the near about mid range, you use the indium, and the higher range you use zinc for the calibration of your DSC. Okay friend, so enthalpy calibration is performed by heating a standard. So how we perform this type of calibration, we have to discuss this on my next video. What is the procedure for the calibration of differential scanning calorimetry? If you want to see the video, please comment yes for the calibration of DSC and TG. I will make the video and post it. Okay, what is the procedure for the analysis of any substance in DSC? Just the procedure I described. Accurately weigh an appropriate quantity of substance to be examined in the crucible. Okay, just weight a substance in a crucible, make a pinhole, crimp it with the help of crimper, and put in the DSC. Okay, typically it should be performed from room temperature to their decomposition temperature with the heating rate of 10 to 20 degree or 1 to 20 degree per minute. Okay, in future I have also made a video on how to perform the method development on the DSC or the thermal analysis technique. I will upload it later. Okay, this is the one thermogram which I paste here. With the help of this, what kind of information we get? This is the known as the peak temperature, and this is known as the onset temperature. Okay, determine the temperature range bracketing in the transition of intersects such that the baseline can be extracted. Okay, so it is this type of thermogram. In the X, I will determine here. Wait. Yes, the temperature on the X-axis. This is the X-axis, and this is the Y-axis. The temperature where indicate it is known as the X. It is known as the X-axis. The energy change or heat flow, it is on Y-axis. The melting temperature, melt onset temperature is 188.79. It is the melt onset temperature. Okay, and the if you say that peak temperature is 190.31 degree, and what is 1 minus 102.3 joule per gram? It is it is the enthalpy. So it is the whole procedure given in the USP General Chapter 891 for the thermal analysis only for the DSC. I not completed the whole 891 chapter. I only discuss about the procedure, technique, and what information we get with the help of DSC as per the USP General Chapter 891. Okay, thank you friends. If you like the video, if you think this video is useful, please like, share, subscribe and comment. It really motivates me to make more video. So comment to motivate me. Thank you.